because they are literally just several problems. I don't know why she's not here today. She has to leave all the time for sports, but Lexi, we miss you.
I texted her and asked her if she was coming to get me just help.
Yeah, hope she's all right. All right, so these problems are super duper fun because they are going to be chain rule problems that also require the quotient rule. So the first thing I would, and all of your directions are to find the derivative for these. The first thing that I would do for this is before you take the derivative, I would write this as x squared plus 4 to the 1/3 power in the denominator there. And then you are going to use the quotient rule to take the derivative. So for the quotient rule, we've got low, which is going to be x squared plus 4 to the 1/3 times d high, derivative of the high. What is that? 1 minus high, which is just an x. Derivative of the low, here's where our chain rule is going to come in. We got to use the chain rule to take the derivative of that. So it's going to be 1/3 x squared plus 4 to the negative 2/3 times, we have to multiply that by the derivative of that inside stuff right there that we haven't taken the derivative of yet, and that would be 2x all over x squared plus 4 to the 1/3. Oh, I forgot to check homework from last night too. I'll do that at the end. Oh, I'm sorry. It should be, I just wrote that, and it should be squared. Thank you, Xander. Okay, so we're just going to clean it up a little bit. So, like, technically at this point, you have taken the derivative on a free response question. You could be done if they don't need you to do anything else with it, right? Technically, you could be done. But right, yeah, exactly like I have it right here. If all they ask you to do is find the derivative, you could stop if it was a free response question. However, most of the time, these problems are not on. If they are on the free response, you either need them in the next part where it's going to help to have it simplified, or it doesn't show up on that part at all. It's on the multiple choice where they are never going to leave the answer looking like this. Yes?
Did you count that right on the insert, like when it asked for the derivative, it was quotient rule? Like I selected like that.
Yes.
Okay.
Yep. Yep.
Also, did my midterm bonus wind up hurting my grade? Because it was there and now it's gone, which is fine if it's different.
I think what happened is when I went and added the extra points for late work and bathroom passes, it made your test average a little bit higher, which made it not help you anymore, so I took it back away.
Okay.
It barely made any difference because it was very close. Yeah. So once I added late work and bathroom passes, there were a couple of you that I had to drop your midterm bonus because it wasn't helping you anymore. Although it didn't make a lot of difference. For this, to clean this up a little bit here, we're going to have x squared plus 4 to the 1/3 power. And then right here, we've got x, 1/3, and 2x that all need to be combined. So that's going to be 2/3 x squared times x squared plus 4 to the negative 2/3 all over. Whenever I raise a power up to a power right here, what do I do with those exponents? Multiply for powers to power. So like, this is a side note, but like if I've got x squared times x to the 3rd, that would be x to the 5th. That's when I would add. If I've got x squared raised to the 3rd power, that would be x to the 6th. So we need to multiply our exponents here. And that's going to give us x squared plus 4 to the 2/3 power. Now, what we should notice here is that this piece, and this piece are all the same. And if you have something like that happening, it probably means you can simplify further. We cannot distribute this 2/3 x squared because we have a power right here, which we'd have to deal with first, and we don't really know how to deal with that. We cannot move this stuff down to the bottom because there's a minus sign here that separates it. So what we want to do here, we did this some on some of the product rule problems as well. In our numerator, we want to factor out our greatest common factor for our x squared plus 4 terms. So you want to take the lowest exponent that you can take out, which in this case is negative 2/3. So we are factoring out x squared plus 4 to the negative 2/3. And so when we do that, it's like we're dividing by x squared plus 4 to the negative 2/3, x squared plus 4 to the negative 2/3. On that second term, it'll be very easy because they just cancel each other out. But on that first term, what we have happening there, I'm going to do this over here to the side, we've got x squared plus 4 to the 1/3 over x squared plus 4 to the negative 2/3. What should we do with that negative exponent in the bottom? What? We are dividing it. You could subtract exponents. I think of it as like moving it up here to the top, right? So if it's gone from here and we move it up to the top, we've got x squared plus 4 to the positive 2/3. And then when I put those two together, what will I get? 1, right? 1/3 plus 2/3 is going to give us 1. You add those exponents because they have the same base.
How can we just move it up there?
It had a negative exponent.
Okay.
Yeah. So since it had a negative exponent, we can just move it up there to the top. Or another way you can think of it is you are subtracting these exponents whenever you're like factoring that out. So 1/3 minus negative 2/3 is going to be really like 1/3 plus 2/3, which also gives you 1. So when we factor out that x squared plus 4 to the negative 2/3, on this part, we're left with x squared plus 4 to the first power. And then over here, we've just got minus 2/3 x squared over x squared plus 4 to the 2/3. Questions here? It's got more. This right here has a negative exponent. It is multiplied by this other stuff. I can send it down to the bottom. I also, over here, could combine this x squared with this negative 2/3 x squared. So, whenever I do that, I would have x squared minus 2/3 x squared would give me 1/3 x squared plus 4 over, I'll have x squared plus 4 to the positive 2/3 times x squared plus 4 to the positive 2/3. What do I get when I put those together in that denominator? What? 4/3, yes. So it'll look like this. We're almost there, but they're still probably not going to leave it like this. Why would they not want to leave it like this? Well, they might leave the fractional exponent. You could do that either way.
Complex fraction.
It's the complex fraction. It's that 1/3 in the top. How could I get rid of the 1/3 in the top?
The back forward.
You could get like common denominators. Yes, that would work. But Tyler's idea is easier. If I multiply by 3 here, that's perfectly fine as long as I also multiply the denominator by 3 as well. And if I distribute that 3 right there, 3 times 1/3 is just 1. So I'll get x squared, and 3 times 4 will give me 12. Okay. Lots of times they'll just leave it like this. Sometimes they'll change it back to roots. It just depends on what they feel like at the time. If they change it back to a root, it'll look like this. The cube root of x squared plus 4 to the 4th.
Should we distribute the thing on the bottom, or was just the thing?
You cannot distribute it because of that exponent right there. And in general, even if there was no exponent, I would just leave it factored out. But it just depends on what they do with the answer choices. Oh, excuse me. So, lots of stuff going on there. Okay, questions? All right. Let's see. Let me see what all I've got here. We probably won't do both of those. Let's do this one. Much like the last one, I would go ahead and write that as x squared minus 4 to the 1/2 power. I think it makes it much easier to take the derivative. And so we are going to use quotient rule to take this derivative. So we got low d high, what's the derivative of the top? 2. Minus high, which is 2x. D low, here is where the chain rule comes in. We've got to use the chain rule to take the derivative of that denominator. So we'll have 1/2 x squared minus 4 to the negative 1/2 times the derivative of the stuff on the inside, which would be 2x, all over x squared minus 4 to the 1/2 power. Squared, yes, thank you. I always forget that. Okay, technically, you have taken the derivative here. If they've asked you nothing else on a free response question, you could stop. But more than likely, they're going to require you to simplify it one way or the other. So I'm going to just clean it up a little bit first. X squared minus 4 to the 1/2 power minus, here we've got a 2x, a 1/2, and a 2x that all have to be multiplied together. So the 2 times 1/2 times 2, these two kind of cancel each other out. You just get 2. And then you've got 2 x's, so you'll get 2x squared, and then we're just going to put that x squared minus 4 to the negative 1/2 over, we'll have x squared minus 4, to what power will we get there? To just the 1, which really isn't necessary to write there. questions? Okay, so much like the last problem, we've got these pieces that are all the same. So in the numerator, we want to factor out whatever our lowest exponent is for that x squared minus 4 term. And so in this case, that is 1/2. Or negative 1/2, I'm sorry. So we will have x squared minus 4 to the negative 1/2. And so when you factor this out, you are like dividing by x squared minus 4 to the negative 1/2. Okay? On that second term, it just cancels out. But on the first term, what are you going to get whenever you do x squared minus 4 to the 1/2 over x squared minus 4 to the negative 1/2? Yes. So we will get, the 2 just sort of stays there. We will get x squared minus 4 to the first power, which we don't really have to write since it's first power. And then we'll get minus 2x squared from that second term. And then we'll get x squared minus 4 in the bottom. Still got a little work to do. I think that's the trickiest step right there. Questions? Okay. So we want to send this back down to the bottom because it has a negative exponent. And we're just going to simplify whatever we can out of the top over here. So that is going to give us 2x squared minus 8 minus 2x squared over, we will have x squared minus 4 to the 1/2, x squared minus 4. The 1's unnecessary, but I'm going to put it there so we can think about adding those exponents together. And here our 2x squared and our negative 2x squared will just cancel each other out. We will get negative 8. In the bottom, we'll have x squared minus 4 to what power? The 3/2 power. So we're going to add those together. The 1/2 and 1 will give us 3/2. And that's about as simple as you're going to get. They might change it back to roots. If they change it back to roots, you'll get negative 8 over the square root of x squared minus 4 to the 3rd power. Could be either one of those. Okay, questions? I had a third example here, but it is very similar to what we just did. I'm going to skip it. Let's go to this 4th example. This will be our last one. You have some different options for how you can deal with this one. You could rewrite it as like 3x minus 1 squared on top and x squared plus 3 squared on the bottom, and then do a quotient rule. Or you can treat it as a chain rule from the beginning for that. So I think I'll do the chain rule from the beginning. So if we do this as a chain rule from the beginning, all of this stuff right here is our inside stuff. And then to the 2nd power is our outside stuff. So if we take our derivative, we'll begin by just taking the derivative of that stuff to the 2nd power. So that will be 2. Leave the stuff on the inside the same to the 1st power. Right, that takes care of our derivative for the first power, but this stuff right here on the inside, we haven't taken the derivative of it yet. So for chain rule, we have to take the derivative of the stuff in that green box. How are we going to take that derivative? Quotient rule. And so when we do this, make sure you keep like this quotient rule stuff in parentheses over to the side, so that you know it's multiplied there, and we'll have low, so x squared plus 3. Right here, it is so important. Some of you guys are doing this, x squared plus 3 times 3 minus 3x minus 1 times 2x. Some of your work looks like this. What's wrong with that? You have to have the parentheses around the x squared plus 3. You have to have the parentheses around the 3x minus 1. If you do not have that, it is incorrect. Because x squared plus 3 times 3 is x squared plus 9. X squared plus 3 times 3 within parentheses is 3x squared plus 9. Right, there's a difference. So you have to have those parentheses when you're doing that quotient rule. On the midterm, I saw a few of you that had that issue. So to simplify this, you definitely want to simplify that numerator. So you've got 2 times 3x minus 1 over x squared plus 3. And then you'll have 3x squared plus 9. Be really careful here. I'm going to do it all as one step, but you're going to distribute this 2, and there's a minus right here that has to get distributed as well. Should I do that together? You're going to get you'll get 6x squared, but it needs to be a negative 6x squared. And then you get negative 2x, but it needs to be a positive 2x because of that negative that gets distributed. We got x squared plus 3 squared. And that is going to be negative 3x squared plus 2x plus 9 over x squared plus 3 squared. When you multiply fractions, you multiply like straight across. So if we put this over 1, you will probably see them put these two pieces right here together because you've got x squared plus 3 and another x squared plus 3. So they'll probably put that together. I think they'll just leave everything else alone. So it would be 2 times 3x minus 1 negative 3x squared plus 2x plus 9 over x squared plus 3 squared. Oh, not squared, cubed. There. Yes. Yes.
When you said the notes were over, I was waiting.
Alright. Yeah. Y'all want to write your name on the board? No. Well, we could all line up like in kindergarten, and I'll take y'all all to the bathroom at one time. I'll ask you if you remember to wash your hands as you come back out. Okay. All right. So your assignment is actually, let me look on Canvas. It's not, I think I had different ones on Canvas.
Actually, it's a perfect day. There's no girls going right.
Let's go one at a time. Don't want y'all meeting up out there.
Oh, no.
Apparently apparently last year the bathroom down there next to Coach Wood's room was a very romantic place. I don't know.
I know he probably went that way. No, Maggie, you're gonna meet up with
Go ahead, Maggie.
Yeah, I'll plan on it.
All right, let's see. Where, Lexi, here's the homework, 27, 28, 29, 31, 33.